Here we're going to review the linear search algorithm. Now the purpose of the linear search algorithm is to find a target item within a list. So what happens is that first element in the list is compared with the target value, and then the algorithm keeps comparing successive items in the list until a match has been found or until all items have been checked. So when the match has been found, the position of that item in the list is returned. If the item has not been found in the list, then the program will run right through to the end and then return some sort of suitable message to indicate that the item hasn't been found. If there are two or more items in the list, the target position of the first item will be returned. And we can use any data type, so we can use integers, typically strings or characters within our list and within the items that we're searching for. The algorithm will run much faster if our target item is nearer the start of the list than at the end of the list. So the algorithm itself runs in linear time, and this is determined by the length of the list. So therefore, if our list is longer, our program will take longer to run on average than if it's shorter. At the best, it will make one comparison, so that is if our item is the first item in the list. At worst, it will take however long our list is, so it'll do that number of comparisons for the length of the list to find the last item in the list. But on average, it will take n plus 1 over 2 comparisons. This is a slow algorithm compared with other search algorithms. So let's have a look at how the algorithm works. We're going to apply it to this sequence here. So V, A, S, Z, X, R, T, and G. So that's our list and also the corresponding index position. So our aim is to find the position of the letter Z. So we know from here that that's in index position 3, but we're going to apply our algorithm to figure that out for us. So first of all, we compare our target value Z with the value in index position 0. So that's clearly V. Well, obviously they're different, so therefore we need to move on to the next index position. Next, we compare the value in index position 1, which is A, with Z, and again, they're different, so we move on to the next index position. Again, we still haven't found Z, because we compare it with S and they're different. But we get to index position 3 and we compare our value with our target and they're the same, so therefore our program returns the index position and then stops. So let's now trace our linear search algorithm. So we have a list of items, there's 10 integers there, and we have that indicated against the index position, so you can see this on the top right hand side here. So the first stage is to load those integers into a list called items, so that happens on line 7. On the next step, we identify our target value, so this is number 32. Then the algorithm determines the length of the list, which contains 10 items. On line 3, the algorithm iterates through the list, so it starts at the first item, so item in position 0. We then compare the item with the target value, so the first item in the list is 17, target value is 32, so clearly they're different. Then we move on to the next item in the list, so we're now in index position 1. We compare that value, which is 2, with 32, and again they're different. So we continue through the list and move on to the next item. So now we're in index position 2. And again we compare the value in index position 2 with 32, and they're different because the value in index position 2 is 5. So again we go back to line 3. So now we're in index position 3, which is the value 21. We compare that with the target value. Again, they're different. So now we go back to line 3. Now we're in index position 4. The value in index position 4 is 32, and we compare that with the target value. So now we have found our value. Now the index position is returned. So the index position is 4. And then that index position is output. If the target item is not in the list, the value of -1 is returned in this case.